Hello dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. So in this lecture series of this solid waste subject, today we will deal with the sampling of solid waste. So before that we discussed about the collection of solid waste. And now we're going to discuss about the sampling of solid waste. So first of all, this solid waste sampling is which type of sampling should be done and which is the best method to do the sampling to get a best result, because sampling is very much important as to understand which method is needed for the sampling of this solid waste, for the disposal of this solid waste, and in which season it should be done. So know the characteristics of the waste. First of all, to know the characteristics of the waste means which type of waste characteristics, and then origin. To know all these things, this sampling should be done. So MSW composition and characteristics vary considerably, not only between cities but also within the urban local bodies, that is having daily, seasonal and temporal fluctuation are usually observed. Exactly. This MSW sampling should be done to know the characteristics of the waste, and this waste characteristics has been varied depending on the cities, depending upon the persons, depending upon the location, like it is a local bodies or it is in city, or it depends on the season also. So there are many points that will on which the solid waste characteristics is depend. First of all, it depends upon the between cities. It will vary between cities. It will depends upon the either it is a rural area or it is a rural area or urban area. And then origin and living standard of the persons they are living in that particular locality. So there are many factors that is responsible for the characteristics of the solid waste. And MSW is a heterogeneous in nature that consists of varied many waste fractions requiring multiple sample at multiple location. So because MSW which we are dealing with, like municipal solid waste, is an heterogeneous mixture. As we have already discussed, like MSW will having the mixture of paper, some food waste is there, some glass is there, some construction and demolition waste is there. So all these are considered under this MSW. So this, as we know, this is a heterogeneous in nature because many type of waste is present in this just in a single word MSW. So to know a proper disposal method for that waste, this sampling is very much important. And the it will require varied waste fractions requiring multiple sample at multiple location. So at a single location site, at a single disposal site, it requires multiple sampling as well as multiple fractions also. So now we are going to discuss about the type of sampling method. Which method should we adopt to get this proper sampling? Now comes to the next point. This first type of sampling is a quartering sampling. Quartering sampling and coining method is a very mostly used method of this solid waste sampling. So this quartering sampling or coining sampling is the best technique for determining the composition and characteristics of municipal waste. I think this method has been adopted mostly in our country, and this method has been developed by the NEERI. NEERI, you know, NEERI, National Environmental Engineering Research Institute, Nagpur. Nagpur, it is there, National Environmental Engineering Research Institute, Nagpur. They have developed this quartering sampling method. So in this sample is reduced to a more manageable size as the actual classification is carried out by hand. So this method should be adopted to reduce the more manageable size, and the actual classification is mostly carried out by the hand. Selection of sampling size is the critical first step in this process. So in this process, first of all, you will do the site location, means which site is represents the best represents the mostly garbage, because this garbage, this solid waste will represents mostly. It depends upon the location. Maybe sometimes more paper waste is there, sometimes more food waste is there, sometimes more cattle waste is there. You don't know this garbage will have which type of waste more, because depending upon the area, like if it is nearby to residential area, if it is nearby to a commercial area, or if it is nearby to a school or hospital. So depends upon the location, depending upon the origin, the waste nature will be varied. That's why this sampling, in this sampling method, first step is to choose a location from which sampling site should be selected. And this is a very critical step, because you don't know which, in which sampling site you get a homogeneous waste like mixed waste. If we will get solid waste, mixed waste like heterogeneous waste, then this will be good to predict something. But if either it is nearby to a school or any office, so mainly we'll get which type of waste, we'll get more paper waste. If it is nearby to a restaurants, then we'll mainly get food waste. So this type of waste selection, to get to done the proper sampling, waste selection point is also important, because this one only will define, will choose which method should be good for this one. Now, there are some aspects which should be considered during sampling. So, during sampling, what are the important points should be keep in mind? First of all, waste sampling site and frequency of sampling. First thing will be in mind is the sampling site. As I have already discussed, like sampling site means which site should be selected for the sampling method. Like in which site will get homogeneous or heterogeneous mixture of solid waste, because to obtain a heterogeneous mixture is a main point regarding this solid waste. So heterogeneous mixture of this solid waste will get the sampling site and frequency of sampling, like how much if we will choose a sampling location, then we have next point is to we have to select how many times we should go for sampling, either 2 times or either 3 times. And next point is related with this is the sample collection site should be representative. So this site should be representative, means it will represent all type of waste. So it will be representative to the particular waste nature, representative to particular waste nature, to waste nature. So these are the important thing that should be keep in mind while doing sampling of a solid waste area. It should include residential area, including slums also, commercial, business, market area, vegetable market, meat market, slaughterhouse, grain market, etc. So if it will be mixed, why we are giving the name of this type of area, like a residential area, commercial area, business area, market area? Because it will, then only it should becomes a heterogeneous solid waste. If we will cover more and more type of waste generation area, then the waste should be heterogeneous in nature, heterogeneous in nature. And next point is that sample site should be representative of all income group within the urban local bodies. Means main point is that it should be representative of all income group, all persons, because it should be for a lower class person, middle class person, or high class person. Depending upon the person's classes, income group, waste size also will also differ. So if we'll talk about high class people, will get more paper waste. If middle class persons are there, they are mostly all type of waste, homogeneous waste. But in the slum area, mostly the waste is the food waste like this. So this type of selecting waste side should representative of all income group. All income group people should representative of this income group. In this we'll get idea about what should be the important factors and that should be considered during the sampling site. First is the waste sampling site and frequency of sampling. Next is the sample collection site should be the representative, and this sample site includes the residential area, like some slums, and commercial space, business market and market area, some slaughterhouse, grain market, or vegetable market, or meat market. Next point is the sample site should be the representative of all income groups within the local urban local bodies. So these are the important factors that should be keep in mind while selecting a sampling location for the solid waste management. Now we'll give one example of this sampling method. What This method has been given by a case study in Nagpur, India by Chandramani Bhimrao Patil et al. This is the method of sampling of solid waste. This is an example we can see that. First of all, we have to take 100 kg of waste. So 100 kg of waste can be divided into 4 quarter. 4 quarter is there to up to 25, 25. 4 quarter is there. That's why the name is the quartering sampling method. All waste should be divided into the 4 quarter. So, if it is in 100 kg of waste, it should be divided into 25, 25. Among 25, 25, by this quartering method, again select 50 kg of the waste. And then 50 kg is of the waste will be divided into the 4 quarter. Again, if with this 4 quarter, you can extract 25 kg. 25 kg can be divided into 6.25 up to 4 quarter. With this 25 kg, you can extract 10 to 12 kg of sample. 10 to 12 kg of sample, and this sample will go for the physical analysis. In this way, you can get idea about the type of waste. Type of waste. And this is the 10 to 12 kg of sample can also go for the chemical analysis. Chemical analysis will also did for the same waste, so you can get idea about the basic characteristics of the waste. So this quartering method is a mostly adopted method for this solid waste sampling. Like you can select 10 to 30 number of sample. From 10 to 30 number of sample places, you will take, first of all, you will take 100 kg, and then 100 kg into 4 quarter. This will reduce 50%. Like then select 50 kg. 50 kg in 4 quarter, and then by coining and quartering method, you can then again extract 25 kg. In 25 kg, by coining and quartering method, you can extract 10 to 12 kg only. With 10 to 12 kg only, you will go for the physical analysis or either for the chemical analysis. In this way, with the physical and chemical characteristics of the solid waste, we can understand. So for this physical analysis, what parameters we should study to know the physical analysis? For physical characteristics, what methods you should use? First of all, physical characteristics will define what? Physical characteristics of solid waste are important for the selection and operation of equipment and for analysis and design of disposal facilities. For the analysis and design disposal facility, or either for the selection and operation of the equipment, this physical characteristics is important. First of all, first is the to choose the operation method. Which operation method should be adopted? Next is the operation of equipment. Next point is design and disposal facility. To know the disposal facility means disposal facility, like either landfill should be done, or it will go to the MRF facility site. So like this physical characteristics will reflect. And the compositional analysis, first is the compositional analysis. Compositional analysis will deals with the composition analysis of this waste. So first, the wastes are separated on the basis of physical properties like dry, wet, paper, glass, metal, household hazardous, construction, and mixed or either miscellaneous. So this can be divided on the basis of the physical property, physical appearance. In physical appearance, what? Either dry waste is at one place, wet waste to one place, paper at one place, glass or metal, or some any household hazard is there, or some construction and some mixed or some miscellaneous kind of waste. In this way, you will segregation should be done on the basis of the composition, on the basis of the physical appearance of the waste. This we can also term as waste segregation. Segregation at initial level, like on the basis of physical property, they are weighted and are represented as a fraction of total waste. Then again, that method has been adopted, like this quartering method. What quartering method? In quartering method, first of all, quartering method should be adopted. They, on the basis of the physical appearance of the waste, they can be divided into different properties, physical properties. Depending upon their physical property, they can divide into different categories, like dry waste, wet waste, paper waste, glass waste, metal, household hazardous, construction, and mixed miscellaneous waste. they are weighted and are represented as a function of total waste. So then they can be weighted and they can be represented as a fraction of total waste. Total, how much amount of total waste is there, this will be a representative sample for the fraction of total waste. And the point is related with this one is the selection and operation of equipment and facility. It's a significance, how, why we are doing this type, this all these steps. So this step will be helpful in the selection and operation of equipment and facilities, and design and disposal facility. So these are the important significance for doing this physical characteristic. Significance is that we are doing all this quartering method for this weighting, for the first of all we'll weight the sample and we'll make the representative sample, like for dry waste, for wet waste, for hazardous waste, for construction waste. Representative sample will be there, and this representative sample will be selected, will be done, will be at one place to get a proper selection and operation of equipments, and the facilities should be adopted, and then we can get idea like which type of design of disposal facility should be adopted for that particular kind of waste. Now, variation in composition, like the compositional variation will vary. This composition will vary depending upon the location, season, and economy. As we already discussed about all those things, like location and season and economy of the people, means like income group, which type of income group people are there. Location is like if the commercial activity presents the food type hilly or plain and warm or cold. The location is like that, either it is which type of food is there, it is on a hilly place, or it is on a plain place, or warm place or cold place. And the commercial activity is there, which type of activities are there. So weather, depends on weather also. Next is the season. Which season is that, like on one of the key factor affecting the generation and composition of residual waste, because season is the very important parameter regarding this sampling of this solid waste. Because if we will take the sample before monsoon, like in a pre-monsoon area, the pre-monsoon size, the sampling characteristics is the waste characteristic is very different. In a rainy season, if you will take the sampling of the solid waste, because due to rain the solid waste characteristics will be changed, because rainwater will come and rainwater will causes will during, because of leaching, the leachate will be collected inside the this solid waste. That's why this season also the waste characteristics before monsoon, in the monsoon, or post monsoon season is very different. That's why the season is very important. You can take a sampling either on all the three seasons, like before monsoon, at the monsoon, pre-monsoon, monsoon, and post monsoon. And the economy will also play an important role in the sampling of solid waste, like fraction of dry waste generated from HIG house is high compared to that of LIG house. Obviously HIG house, high income group people or lower income group people. So HIG people is like the waste or dry waste generated is more, or lower income group is like a little bit less. So this three things are there that will be defined, that will represents composition of the solid waste. First is the location, season, and economy. Now comes to the this is the representative of the waste characteristics in our country. So you can see that with the blue color it is representative biodegradable samples. In the this is the three type of years, like compositional variation of MSW. If we compare with the 10 years of data, so in 1996 all mostly waste are generated is the biodegradable waste and some glass material, or either inert gas, inert type of waste is more, and the paper waste is little bit less. In 2005 this biodegradable waste is also again more. Obviously biodegradable waste is more anytime, but the plastic and rubber waste has been increased. Before this plastic and rubber waste is very less, because at this time people are not much dependent on the packed food or ready to eat foods, this type of things. Now this has been changed in the year 2005, and 2011. If you see the 2011, the this plastic waste and plastic and rubber waste is increased. Plastic and rubber waste is increased, and biodegradable waste is also more, but this inert gas inert waste is also reduced because waste segregation has been started. So with waste segregation, person can know which waste should be in which category. So before that, inert gas, inert type of waste material is more. Now inert is also less, and waste can be divided into different categories. So paper waste is also increased, plastic and rubber waste is increased, biodegradable waste is same, but inert material is reduced. So this is the compositional variation of MSW in India if we compare the 3 years, 3 seasons. So this reports has been given by Planning Commission report in the year 2014. This will give idea about the compositional variation of MSW and why this sampling is important. You can understand by this data, like this sampling is important, and the because of this only we can compare the data, like which type of does we have to improve our disposal methods, or it should be like that, because in on every 10 years waste characteristics has been changed because of the variation, because of the either because of the weather or because of the income group people, everything is changed. So you can also see that by in this data. Now comes to the next point, that is the next physical parameter is the density. Density represents mass per unit volume. Density is mass per unit volume, per unit volume, kg per meter cube. This is the density only, and it is a critical factor for the design of solid waste management system, because to determine a solid waste management system, like the design of sanitary landfill or the storage capacity or the type of collection and transport vehicle, this density is very much important, like up to which this amount of space, how can we can put how much amount of solid waste. So it is a critical factor in, because if we when we are going to design the solid waste management system, either a hall container system or a landfill, then first thing will come in mind, like this much of a space can occupy how much amount of solid waste. So that's why this density, to know the mass per unit volume of this solid waste is much important. So to put the solid waste in a particular landfill, how much amount of density of the waste that is generated and how much density you know you want in this sanitary landfill is compared, and then on this basis you can design a landfill, or you can select a collection vehicle, or you can select a collection method or storage of solid waste, or the density design of a sanitary landfill. That's why this density is very much important while studying this physical properties of the solid waste. Next point is the moisture content. Moisture content can be defined as the ratio of the weight of water, like wet weight or dry weight, to the total weight of the wet waste. Is a moisture, means what, the ratio of the weight, total weight of water with the water, how much amount of water is there, and with the ratio of the either wet weight or wet weight or dry weight, and the total weight of the wet waste can be considered. And moisture increase the weight of the solid waste and thereby the cost of collection and transport. Moisture increases, like if moisture is more, the weight of the solid waste is increased, and if the weight will increase, the cost of collection, the transport, then the operation, all will increases. That's why the to know the moisture content of a particular waste is very much important. Or if it is a dry weight, means no less moisture is there, then the weight is already reduced, so it will be a feasible method. If it is a wet waste, then the weight is more, thereby the cost of collection and transportation, everything will be increased. So we have a study the physical characteristics related to the solid waste generation. So density and moisture content, we'll deal with it. Next, we are going to know the formula of this moisture content. So moisture content can be calculated in the percentage, is equal to moisture content percentage is equal to wet weight minus dry weight divided by wet weight into 100. So a typical range of moisture content is 20 to 40%. Mostly range of the um, solid waste is 20 to 40%, representing the extreme of waste in an arid climate and the wet season of a region of high precipitation. However, value greater than 40 is not uncommon. 20 to 40% is the mostly characteristic of the waste. This will represent the general characteristics or extremes of waste in an arid climate or wet season. If it is a wet season, obviously this will be moisture will be high because of rain and everything. So the most of the in general will get 20 to 40% of moisture in any solid waste. Now, specific weight. Specific weight of this is also an representative of this physical characteristics of solid waste. Specific weight can be defined as the weight of the material per unit volume. Per unit volume, the weight can be defined is called as a specific weight. Generally, high waste density 400 to 600 kg per meter cube is observed in India, maybe because of high amount of inert material. Most of the waste density, higher waste density 400 to 600 kg per meter cube is observed in India because of high amount of inert material. It is helpful to know the collection vehicle capacity and landfill capacity also. It often reported as a loose as found in containers, uncompacted or compacted. So a specific weight can be calculated by the given formula. Weight upon volume. Total weight of the solid waste divided by the volume of the solid waste. This specific weight is very much helpful to know the collection vehicle capacity and landfill capacity also. And generally the higher waste density is 400 to 600 kg per meter cube, and it is mostly observed in India, maybe because of high amount of inert material. And the a specific weight, normally if we'll talk about the specific weight, it can be defined as the weight of a material per unit volume. And the range, the trend of this specific weight in Indian solid waste is 400 to 600 kg per meter cube. And it is observed in India maybe because of high amount of inert material. It is helpful to know the collection vehicle capacity and landfill capacity also. It is very much helpful to know the collection vehicle capacity as well as the landfill capacity also. It can be reported as a loose as found in containers or uncompacted or compacted. So a specific weight is equal to specific weight is equal to W upon V, where W is the weight of the solid waste and volume, V is the volume of the solid waste. Now comes to the next point, that is the particle size. So measurement of size distribution of particle in a waste stream is important because of its significance in the design of mechanical separator and shredder. This particle size measurement is very important because this waste stream is important because it significantly it will design with this only we can design the mechanical separator or shredder for the particular waste. So the size of waste component may be defined as a one or more following equation. So you can see that size of is equal to L. So L plus W upon 2, L plus W upon with H, like the length in mm or width and height. If we'll consider all three, so the particle size SC is equal to L plus W plus H, length plus width plus height divided by 3. So it is equal to L into W 1 by 2. And size capacity particle size is equal to L into width into height to 1 upon 1/3 of it. So this is the final formula we can obtain for this particle size. And this particle size can be important, and it is very much important for the to know the design of a mechanical separator or a shredder, because this mechanical separator and shredder can take up to some amount of particle size. If its size will be more, it cannot be separate or it cannot be do the shredding part. That's why this particle size calculation is very much important before entering it into the shredder or any mechanical separator. SC, as we know, SC represents size of component in mm. L is equal to length in mm, W is equal to width in mm, height is equal to H is equal to height in mm. So final product we'll get is like S size particle is equal to length in mm into width in mm into H, and divided by 1/3 of it. Okay, now comes to the next point. This is about the filled capacity. Filled capacity of MSW is the total amount of moisture which can be retained in a waste sample subject to gravitational force. So the field capacity of MSW is the total amount of moisture that can be retained in a waste sample that will subject to a gravitational pull. It is a critical measure because water in excess of the field capacity will form leachate. Water in excess of field capacity will form leachate, and leachate can be a major problem in landfill. In a landfill in a rainy season, this leachate will be a major problem. And the field capacity vary with the degree of applied pressure and the state of decomposition of the waste. So this field capacity vary with the degree of applied pressure and the state of the decomposition of the waste. So this field capacity should know the total amount of moisture which can be retained in a sample subject to a gravitational force because of this gravitational force, and it is a critical measure because water in excess of the field capacity, if this field will having a more water, then this will be form leachate, and this leachate in landfills, this leachate is a very major problem. This field capacity vary with the degree of applied pressure and the state of decomposition of the waste. Now you can see in the picture, like this picture is showing the field capacity. So this is the solid waste. So in the rainy season the rain will come, like this field capacity, rain will come, and this saturation will be done, and this is a field capacity. So it will be the water in excess of the field capacity will be released as a leachate. So this will be released as a leachate. That's why this field capacity should be known before dealing with a solid waste, because field capacity will contributes toward the collection of leachate, toward the formation of leachate, and leachate is a very polluted thing. Leachate is a very dangerous thing because the waste in a waste, as we know, many many toxic chemicals are there. So in the rainy season, due to water, this leachate will enters into the groundwater due to this field capacity. That's why to control leachate or to collect leachate is a very important challenge during this in this landfill site locations. Now next is the permeability of compacted waste. So the hydraulic conductivity of compacted waste is an important physical property because it governs the movement of liquid and gases in landfill. So the permeability depends on the other properties of solid waste material, like include the pore size distribution, surface area, and porosity. What is this porosity? Porosity represents the amount of void per unit overall volume of material, and the porosity of MSW varies typically 0.40 to 0.67 depending upon the compaction and composition of the waste. So this is about the permeability of the compacted waste, because the permeability depends upon the properties of the solid waste material. This will include the size distribution, surface area, and the porosity. Porosity represents the amount of voids per unit volume of the material, and the porosity of MSW will vary from 0.40 to 0.67, and it will depends upon the compaction and composition of the waste. So next is the porosity. As we discussed, like what is this porosity? So porosity of solid waste, N is equal to E divided by 1 plus E. E is the void ratio. E is equal to void ratio. Void ratio of the particular waste. So in this solid waste physical characteristics, this void ratio is very important. Next is the compressibility of MSW, means like the degree of physical changes in the suspended solid or filter can cake when subjected to pressure. So how much pressure it can hold to change its a pressure. So it can be calculated with this given equation, like HT is equal to delta HI plus delta HC plus delta H alpha. This T is the representative of the total settlement, I is the immediate settlement, and C is the consolidation settlement, and alpha is the secondary compression or creep upon this solid waste, upon this waste. So the physical change of the suspended solid or filter can be subject to a pressure. Because of the pressure, maybe this physical change will occur, because during the storage of the solid waste or putting it in the landfill, this physical characteristics is very important. This will define the characteristics of the solid waste. Now in this lecture I have discussed about the sampling of solid waste and the physical characteristic that should be considered while the disposal or processing of a solid waste. So with this conclusion, I would like to conclude my topic, And if you have any queries or any question regarding this lecture, or regarding any query regarding this subject, you can write in the comment box, or you can directly mail me in my given mail id, shikha.pndy@gmail.com. I will try to clarify your doubt. Okay, and thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.